Hello, and welcome to this module on the OCI database service. After completing this lesson, you should be able to describe the options of database systems available with Oracle Cloud Infrastructure, understand the features of the database service, and be able to launch a one-node database system. The Oracle Cloud Infrastructure Database Service provides a mission-critical enterprise-grade cloud database service that includes comprehensive offerings to cover all enterprise database needs. This includes the Autonomous Data Warehouse, Exadata, Real-Time Application Cluster or RAC, bare metal, and virtual database nodes. The service also includes complete lifecycle automation from provisioning to patching to backup and restore. The system also includes a variety of high availability and scalability options such as RAC, data guard, CPU scaling, and storage scaling. Because this is a cloud-based service and the database instance will run within your virtual cloud network, the security options run the whole entire gambit from identity and access management or API level access, security lists or network level access, and audit logs to identify if and when things are changed in regards to your database instances. It will help you identify what changed, when it changed, and who performed the change. There's also transparent data encryption enabled by default across the board, and existing OCI platform integration giving you the ability to perform tagging and identify limits and service usage integrations. The Oracle Cloud Infrastructure Database Service also offers a bring your own license option. So for customers migrating their on-premises database workloads to OCI, if they already own those perpetual database licenses, there's no need to purchase additional licensing. The Database as a Service offers unparalleled database experience. This gives you all the benefits of the Oracle database and the cloud in one easy-to-use package. This includes all the advanced options that are available with Oracle database, includes things like data guard, RAC, and other Oracle database features. It includes the ability to easily provision a new database with a click of a button, a single API call, or automation tools like Terraform. You're able to scale your database up or down depending upon needs, and this can be done in near real time without having to take any downtime. And because it is cloud, you only pay for what you use, or you pay as you go. So it's very easy to spin up a database system, use it for a short period of time, and spin it back down without having to pay any additional charges beyond the actual duration of usage. OCI with Oracle Database gives you the best database performance anywhere. No exceptions. The OCI database can grow in performance up to 4.5 million IOs per second from a storage performance perspective. That's nearly 10 times what any other cloud provider is able to offer today. With built-in support for Oracle Exadata engineered systems, customers can harness the world's most optimized database hardware for high-scale transactional, analytic, and data warehouse type databases. Customers will also pay less than before, and they'll pay less than other clouds. Customers can bring their existing database licenses, which reduce costs significantly. And if we compare this with Amazon Web Services, a database in Oracle's cloud will cost half as much to run. It also provides up to twice the input-output, or disk level performance. It can grow to 7 times as large, and a basic comparison here would be a 16 OCPU instance with 6 terabyte database. That's the cost structure versus a 16 vCPU instance on the AWS Relational Database Service platform, which would include a 3 terabyte database at this time. Now, there are a variety of database use cases. Anything mission critical can be brought to the Oracle Cloud Infrastructure. This includes support for very large databases. With an Exadata system, for example, customers can bring databases that are upwards of 330 terabytes of total storage. This, of course, utilizes three-way mirroring at the disk subsystem level to ensure the highest possible durability of that data. Another use case includes database consolidation. By leveraging containerized databases, such as pluggable databases, customers can implement multiple databases on a single node, even if those databases are individual or independent tenants from one another. The database service is also ideal to bring applications unlimited to the cloud, things like eBusiness Suite, JD Edwards, PeopleSoft, and Siebel. These applications have a growing set of tools to assist customers to lift and shift and move and improve on-premises applications to OCI. The database service is also great for non-production systems like dev, test, and QA. It's very easy to spin up a low-powered database for things like test environments, or easily create or duplicate environments for quality assurance testing using the VM database instances with the backup and restore capabilities that we'll talk about later in this module. The Oracle Cloud Database or Oracle Cloud Infrastructure Database platform is also great for migration conversations with customers. So if a customer is looking to move from on-prem to the cloud, that first step might involve either utilizing OCI as a DR strategy to replicate their on-premises databases to the cloud, or they might look at migrating some of their initial database workloads to the cloud, at which time they will typically find better performance and lower cost, which enables us to further that whole land and expand conversation with the customer to help them move additional workloads, reduce cost, and improve performance overall. Now, on the virtual machine side of the house with the database service, there are a wide variety of options available. Similar to the compute model, we have nodes running from 1 to 24 cores total, with network capacity of between 600 megabits per second and 24.6 gigabits per second, with the ability to deploy a 2-node rack or real-time application cluster with essentially the click of a button. Now, if a customer provisions rack on the virtual machine database service, this also includes an additional network interface of up to 25 gigabits per second for communication between those rack nodes. As with all VM database instances, customers can scale the storage in near real time. So they can start with as little as 256 gigabytes of total storage, scaling up to 40 terabytes of total usable storage for their database system. Now, the database running on a virtual machine is pretty similar to bare metal shapes. Same look and feel, same process for launching an instance. The one key or the two key differences here is that on a virtual machine, customers are limited to one database home, so single database per virtual machine. On the other hand, with the virtual machine instances, customers can provision a 2-node rack simply by choosing the number of nodes when provisioning a new virtual machine database instance. The important thing to point out here is that rack does require at least 2 cores per node. So if you select the shape of standard 1.1 or standard 2.1, you will find that the node count is hard-coded to 1 and that value cannot be changed. Some additional benefits of the database cloud service. Again, it's cost-effective and it's flexible. So for non-production workloads, we can select from anywhere between 1 and 24 OCPUs, helping reduce cost and helping to right-size the particular database for the workload. It's incredibly easy to get started. So we can create a single database node with a few clicks of the button, a single API call, and we can implement rack, again, with very minimal additional configuration. There are additional built-in high availability constructs, rack, which we've talked about, and DataGuard as well. And we're able to scale storage on the virtual machine instances in real time, and we can scale CPU on the bare metal database side. Now, if we take a look at the bare metal database system here, it's comprised of a single database node. It's a single bare metal server running Oracle Linux 6.8 with local attached NVMe storage. This gives us a single node with very high disk performance, a large number of CPU cores, of course, and a very large amount of local RAM or memory. This allows us to scale the CPU from as little as 2 all the way up to a maximum of 36 or 52, depending on the shape of the instance. And if we plan to implement DataGuard, it enables us to deploy DataGuard to 2 bare metal shapes in different availability domains, giving us a very high level of availability. Now, a couple different shapes available on the bare metal database side. We have the X5, which is the the legacy shape. And we have the X7 shapes, which are the modern 52 core shapes with just over 51 terabytes of local NVMe storage, with the ability to scale from 2 to 52 cores total. Now, on our database service instances, we're using the ASM, or Automated Storage Manager, behind the scenes to manage all of the storage on the host, whether it's bare metal or virtual machine. So the storage ASM is actually going to be continuously monitoring this storage for failures, for errors, or anything else that might potentially impede performance. In the event of any sort of anomaly at the disk level, ASM will actually offline that disk and present error messages in the logs that would enable us to identify the issue and recover. On the VM, virtual machine side, ASM also helps take care of all the disk scaling. So if we were to scale from 1 terabyte to 4 terabytes of total storage, new additional volumes would be presented up to the host. ASM would create the appropriate disk group or logical volume, and then help with the redistribution of data to the new volume, and then at which time we would detach and deprecate the old drives. This again enables storage scaling on the VM side without any downtime and with almost no impact to the usability of the system. Storage on the bare metal database shapes is seen here on the slide. So even though we indicate a total raw storage amount, remember that these are local NVMe drives that comprise storage. To ensure the best possible performance and the most redundant configuration available, these drives will then be converted into disk groups utilizing the ASM, or Automated Storage Manager. Now, customers have an option of either two-way or three-way mirroring. Three-way mirroring, of course, gives us the most or the best possible redundancy at the cost of a little extra storage overhead. So that 51 terabytes of raw storage becomes about 9 terabytes of usable data storage, with 2.3 terabytes of storage set aside for the recovery files. Now, the Oracle Database Exadata Cloud Service is, of course, available, giving customers all of the benefits and the performance and the flexibility of Exadata, coupled with the benefits of operating in the cloud. So it provides the ability to scale out compute, scale out storage, leverages the InfiniBand fiber interconnectivity within the appliance itself, and includes flash memory for very high performance, very low latency analytical activities, where we can actually load our database tables into memory for a period of time for the best possible performance. Now, this slide serves as a great reference to the different shapes and the configuration options with the Exadata database shapes. Rather than read through this, I would offer or invite you to simply pause the video and view the different shapes, the different configurations, and just make note of these options. Now, it is important to note with the X7 shapes, we've moved away from a minimum number of OCPUs, allowing customers to provision that shape and scale down to a minimum of 0 cores. This means that the base cost of the rack shape is actually significantly less expensive than the X6 shape, where we had a minimum of 22 OCPUs. So a customer could provision an Exadata system, and when they're not using it, maybe over the weekend or holiday, or some sort of application maintenance where the database is out of scope, they could scale that instance down to 0 OCPUs, saving themselves a significant amount of cost on an hourly basis when that system's not actually in use. Now, the different database versions supported, all the way from 11.2 to 18.1. This is supported across all database shapes, and of course, bring your own license is supported across the board. Now, a new feature recently made available natively within OCI is the Oracle Autonomous Data Warehouse Cloud. The Autonomous Data Warehouse is designed to support all standard SQL and business intelligence tools and deliver scalable analytic query performance. The Data Warehouse provides all of the performance of the market-leading Oracle database in an environment that is tuned and optimized for data warehouse workloads. As a service, Autonomous Data Warehouse, often referred to as ADW, does not require much, if any, database administration. With ADW, you do not need to configure or manage any hardware or install software. You would simply provision the resource and allow Oracle to take care of the rest. Autonomous Data Warehouse handles creating the data warehouse database, performing all of the database backups, patches, upgrades, and growing or shrinking the database as necessary. The Autonomous Data Warehouse does all the tuning itself. So it's automatically evaluating indexes, resource utilization, and performance, and adjusting on the fly to ensure the best possible performance. It's really designed as a load and go service, so you can provision the resource, load your data, and begin analyzing and querying the data that you put in the system. There's no need to really consider any details about parallelism, partitioning, indexing, or even compression, because again, the service handles these things automatically on the customer's behalf. The Autonomous Data Warehouse is also fully elastic. When you start, simply specify the number of CPU cores and the storage capacity for your data warehouse. At any time, you can scale up or scale down the CPU core count or the storage capacity. And when you make resource changes for your Autonomous Data Warehouse, the data warehouse resources automatically shrink or grow without requiring any downtime or service interruption. Autonomous Data Warehouse is built on the Oracle database, so that business intelligence applications and tools that support Oracle database also support Autonomous Data Warehouse. These tools and applications connect to ADW using standard SQL.NET connections. They also support JDBC and ODBC connectors as well. The tools and applications can either be in your data center or in a public cloud. And Oracle Cloud Analytics and other Oracle Cloud services are pre-configured for Autonomous Data Warehouse, making that integration point easy and effective. Now, a simple visualization of the data warehouse cloud architecture. The ADW system itself includes the database, the service management console, and the built-in tools for accessing this data warehouse. Externally, we could plug in things like SQL Developer. We could use database or data integration services like OCI platform tools, third-party tools, either third-party cloud tools or even third-party on-prem tools. The Autonomous Data Warehouse also supports OCI object storage. So for staging flat files or other imports or exports, we could link to an object storage bucket. And there's a variety of data business intelligence services also supported, either Oracle Data Visualization or the third-party BI tools, either on-prem or in the cloud. Now, shifting gears back to the database service as a whole, the benefits here include complete lifecycle automation. This is things such as provisioning, so the ability to easily deploy a database instance using the latest patches and the latest software available without any additional effort on the customer's behalf. The ability to perform automated quarterly patches and the ability to do automated backups or even manual one-time snapshots that can be used to recreate a copy of an existing database. There's restore capabilities, clone or copy database, and then the ability to maintain, or the option for customers to maintain, full root level access to the host. Now this is a pretty big differentiator from other managed database cloud services. Given that most of the functions are handled automatically by Oracle, yet the customer retains full root level access to the host, means that they can deploy their own custom monitoring tools. They can apply the appropriate application level database patches where necessary, and they can continue to function or monitor and manage that database as they would any on-premises database, while still allowing Oracle to manage and maintain most of the care and feeding of their database platform. Now there's three high availability and scalability options that we've discussed. The infrastructure itself is going to be highly available by design. So we have these three different availability domains within a region. We have fully redundant and non-blocking network fabric. There's the option for two-way or three-way mirrored storage within the databases. So this would be on the bare metal or the Exadata side of things. And then in terms of rack and Exadata, there's the option for, or not the option for, but there is by design the redundant InfiniBand fabric for cluster networking within the appliance itself. Now, the different database options that are available, of course, standard, enterprise, enterprise high performance, and enterprise extreme performance. It's important to note that TDE, or transparent data encryption, is included regardless of the database edition selected by the customer. So every time a customer provisions an Oracle database on OCI, it automatically includes and is enabled by default transparent data encryption. Now, we have a lot of security options available because we're running our database instance in the cloud. This gives us the option to perform instance level isolation. In this instance, we would be using bare metal to do so for workloads that absolutely must run on dedicated hardware. Because the database instance is available and provisioned within our virtual cloud network, we have the ability to control access through isolated subnets, security lists, and VCN route tables. We can also introduce various levels of connectivity by applying VPN or Fast Connect through our dynamic routing gateways to enable access from our external or remote networks to our database instances. We also have a layer of security around the API, so user authentication and authorization. This gives us the ability to compartmentalize database workloads. It gives us the option to control who can perform what type of database function in terms of creating, modifying, or deleting our databases within OCI. As we mentioned, TDE is enabled by default, although customers do have the ability to modify a TDE configuration by using the database CLI tool. In terms of managing database systems, we can of course use the management console, the API, the command line interface, or the SDK to perform any one of these features or functions within our environment. We can launch a new database system. We can check the status of an existing system, start, stop, or reboot a bare metal database instance. We can also scale, again, CPU for bare metal and storage for virtual machines. When a database system is no longer needed, we have the option to terminate that database system. And it's important to note that when you do this, the management console will prompt you asking whether or not you want to take one final backup. That way, if you terminate the database system and realize days or weeks later that you actually needed some of that data, you'll have a manual snapshot that you can use to recover the entire database, allowing you to then locate the missing data. Patching is managed by Oracle automatically, so there's quarterly bundles made available. These patches are evaluated, tested, and then bundled for the customer. And the patching process is as simple as going into the management console and clicking the apply button to deploy those patches to the host. For customers running rack, there's a rolling patch option available to avoid any downtime during the patching process. And if the customer is running DataGuard on a bare metal host, they would have the ability to switch their databases to the standby node, patch the primary node, then switch back and patch the secondary node. It is important to note that on a single instance, be it bare metal or VM, patching does typically result in a brief outage. There are a wide variety of backup and restore capabilities. So when you create a database instance the first time, there's actually a checkbox to enable automated backups. If you enable this, it's going to perform a weekly full backup, a daily incremental backup, and it will retain those backups for 30 days. If you need to retain those backups for longer than 30 days, you can use the DB CLI tool to extend the backup retention. Backups automatically go into an object storage construct where they are available anywhere within the same region via the database UI or the database API. This means I could create a manual backup of a database in one availability domain and use that backup to restore or to create a copy of that database in a different availability domain within the same region. We also have the ability to restore from automated backup. So if a database happens to suffer data corruption or if we lose one or more tables in that database, we could simply select a point in time or a most recent or a particular SCN to do a restore of that database. As mentioned, DataGuard is supported for bare metal shapes. It's as simple as provisioning 2 bare metal database instances. You would then select a database on the first node, choose to enable DataGuard, select the target node, and enter the admin password for the database. Once the configuration is applied, which is done automatically by the management agent, active DataGuard would be in place, giving you some HA, some fault tolerance. And because it is active DataGuard, you would still be able to use the standby or the secondary database node for backups, for reportings, and other query-based activities. Now, in terms of pricing, it is important to note that there's a variety of dimensions for pricing. First of all, we're going to take a look at the database license type, whether it's standard, enterprise, high performance, or extreme performance. That's going to give us a per OCPU hourly rate. So we would simply determine the shape of the VM that we've selected along with the database edition or version, and we'll multiply that hourly rate by the number of OCPUs provisioned. If the customer is using their own license, then there's a slightly different charge for the hourly OCPU cost. So additional considerations here. So this is the X5 instance where license is included, and you can again see the base cost of the instance, which includes 2 OCPUs, and then the additional OCPU cost. Just important to note that OCPUs must be added 2 at a time. So scaling a bare metal database instance can be done on the fly. Customers can scale from the minimum number of OCPUs, which is 2, to the maximum number of OCPUs, which would either be 36 or 52. The cost is per hour. So of course the customer could scale up for a really performance-intensive workload that runs 4 hours, and then scale back down to the minimum number of OCPUs required to run their regular workloads. And the cost does change slightly for customers using Bring Your Own License. You'll notice that the base pay-as-you-go and flex price for the instance is a little bit less, as is the per hour OCPU rate. Again, because the customer is providing their own license, it's not included in the hourly cost. Pricing for the bare metal X7 instances. These are, again, a snapshot, a point in time, and because prices do change frequently, I always encourage people to go out and look at the current online price list to see the latest and greatest pricing available. X7 bare metal, BYOL. And last but not least, pricing for the Exadata X7 instance. Now this is new as of really about a week before this video was recorded. And you'll note that the X7 shapes actually allow more OCPUs. So an X6 quarter rack supported up to 84 OCPUs. An X7 quarter rack supports up to 92 OCPUs. The pricing has changed, the pricing structure has changed a little bit as well, where we offer the rack shape, quarter, half, or full, with a minimum of 0 OCPUs. That means the base price, the intro price, is significantly less than it was before when we required customers to use at least 22 OCPUs. And of course, that was on the quarter rack shape. So the customer can start with 0 OCPUs, which doesn't give them much, but it's a lower cost. To get data loaded where they might not require a whole lot of CPU capacity, the customer could simply provision 1 core per compute node. So that would be 2 on a quarter rack, 4 on a half rack, and 8 on a full rack. This allows them to load data at a very low cost and then scale their CPU capacity up to as high as the shape allows, depending upon their workload requirements. This also means that when the Exadata system is not in use, maybe there's a planned outage, some downtime, or maintenance happening at the application level where the database is not included, they could theoretically scale that shape all the way to 0 OCPUs, allowing them to reduce their cost significantly while the Exadata system is not actually being used. So that is the OCI database service. We looked at the fact that we can run unparalleled database experience with the benefits of OCI and the cloud. The database service offers mission-critical enterprise-grade cloud database services with comprehensive offerings, such as Autonomous Data Warehouse, Exadata, Bare Metal, etc. The service includes complete lifecycle automation, while still allowing customers to maintain full root-level access to the underlying hosts. This again being a significant differentiator between OCI and other cloud providers. The service provides robust security controls and is scalable from one core VM to Exadata shapes with as high as more than 300 cores, and a variety of HA or high availability options. Compared to AWS, the cost is half as much and typically provides more than double the I/O performance versus other cloud providers. And of course, we support a bring your own licensing model for customers who have already invested in perpetual database licenses. For additional resources, check out the documentation here, and we'll see you back soon for the next module.